name is Xin Kang. I'm a graduate student in Geotechnical Engineering, Missouri University of Science and Technology. Welcome to our source lab. Today, I will be introducing you the design and the perform of a bender element test. To start with making a bender element, we need a few tools. As you can see, there are many tools placed on the table. Like this one. This is a mounting meter. It can measure the resistance of a piezo ceramic disc. And also we need a wire stripper to peel off the shield of a cable, a scissors, several nylon screws to house the bender element, and of course the wires to connect the bender element, and some sandpapers, very handy grinder to grind the surface of the bender actuator, and a solder welder to weld the cable to the surface of the bender element, and like a end coating is also called the polyurethane to protect the surface of the bender element, and some silver paint to ground the bender element, and the epoxy to fix the bender element inside the nylon screw. And here's a big vacuum cleaner to clean the cable after test. And this is the piezo ceramic disc. This is for the making the bender element. This is a small piece of bending actuator. As you can see, it has three surfaces. On top and bottom, it's a ceramic plate, and in the center is a piece of metal salvaged by the ceramic, and it's called bending actuator. If you bend, it can generate electricity. If some electricity or voltage is sent to this bending actuator, it can bend. Okay, to start making the bender element, we have to cut the big piece of bending actuator to small pieces. Like this one is too big, and we have to mark it and cut it into small pieces. Then we can start from the small piece and make a complete bender element. This is a small piece of bending actuator. It is cut from the large piece. It's about 1.5 centimeter long and like half centimeter wide. We can use the grinder, as you can see here, to grind off the ceramic on the surface and to let the piece of metal in the center to exposure to the surface. You start the grinder and gently apply to the surface of the ceramic and then grind it. After you grind the surface of the bending actuator, it will like this. As you can see, it's shining. The center of the metal is now exposed to the air, and now we can start grinding or welding, wiring the cable to the bending actuator. There are two types of wiring for a bender element, namely they are a series type and a parallel type. The one, this small piece in my hand, is a parallel type wiring. As you can see, two lines goes to both sides of the ceramic disc, and one line attached to the center of the metal piece. This type of wiring is called parallel wiring. It has many advantages, like it can avoid the crosstalk effect and generate very good signals and receive very good signals. After wiring the bender element, we have to start do the coating. First, we will apply a thin film of the polyurethane. You can use a brush, gently apply to the surface of the bender element to make a thin film outside the bender element to protect the bender element. After apply the polyurethane to the surface of the bender element, we have to wait for about 24 hours so that the polyurethane can be completely dry. And outside the polyurethane surface, we can apply a thin film of the silver paste. The silver paste can protect the bender element. It serves like a shielding and grounding. Here is a bender element, small piece. It's protected by the silver paste, like this. And here are also some bender element after apply the silver paste. It looks like small, tiny silver stuff, silver knife like. A very important thing to notice: before you apply the polyurethane, you do the wiring, like do the coating. Each step you have to check the resistance of the bender element. For example, after you wire the bender element, you have to put one probe to the ceramic and one probe to the piece of metal, and check on the multimeter